Hello, my name is Daniel, and my major is aerospace engineering.
My name is Marvin Dice, and I'm going to be majoring in electrical engineering.
My name is Miguel Mendoza, and I'm majoring in electrical engineering.
And today, we're going to be making magnets dance. Ah, man. There we go.
The materials needed are as follows. Conductive wiring, preferably copper. In this video, we are using 16 gauge. A circular metallic magnet. In this video, we're using a neodymium magnet, a AA battery, and needle nose pliers. In order to balance the wire on the battery effectively, we must take a careful and crucial step to indent the cathode, or in simpler terms, the positive end of the battery. As demonstrated by Marvin in the video, he is using the needle nose pliers to slowly but carefully indent the battery. In order to make the contraption out of copper wiring, you must pull out a strand of wire measured from your hand to your forearm and cut it. Then straighten it out as best you can with your fingers as demonstrated by Marvin. Then you need to fold it in half and slowly squeeze the fold tighter from the cut points to the bent part of the wire. To make the bent point as flat as possible, use needle nose pliers. Slowly bend the wires into arc shapes facing away from each other until it resembles a wide letter M. At the length which the bent end of the wire is equal to the arched wires, you want to slowly bend the wires into a coil pattern, similar to the shocks of a car. Make sure the wires face away from each other like a spiral. Carefully ensure that the wires are equally spaced as if they are a reflection of one another. Test the design to see if it's functional by placing the bent point on the indent of the battery and balancing it. Ensure the battery is placed upon the flat end of the magnet. Adjust the wiring until there is no friction and it becomes functional. If you reverse the polarity of the magnet, it spins backwards, or the other way.
Alright guys, let's try to get a better understanding of what's going on here. I'm going to give you a little informal physics lesson, a little lesson on electromagnetism. I know, sounds scary, but dude, it's really not that bad, trust me. Just go with the flow here. One of the biggest things that we really have to understand is that electricity and magnetism, they're very closely intertwined. In fact, they're so closely intertwined that they're often referred to in the same genre of physics, which is electromagnetism, electricity and magnetism. So they're not the same thing, but rather they're different manifestations of the same force. So if you have one, well, you're going to have the other, or you can very easily generate the other. Okay, great. What does that mean? What I mean by that is, like, so if you have an electron that's moving through a wire, and by the way guys, that's all electricity is. It's just a bunch of electrons moving in the same direction, whether it's through a wire, through space, what have you. That's what electricity is. So anyway, if you have an electron moving through a wire in this direction, just that movement in itself is actually generating a magnetic field around the wire. And the same thing goes vice versa. God, jeez. Sorry guys, this is really strong. Seriously guys, if you have something this strong, which I recommend you don't, but if you do, just be really careful because these things are actually really powerful. But anyway, so you have a magnetic field, right? And you have a copper wire. It's the same thing. If you have a copper wire moving in this magnetic field, that's actually generating an electric current, believe it or not. And the key here is relative motion, guys. So if this wire is just sitting here like this, there's nothing happening because this wire is not moving relative to the magnetic field. It has to be moving in order to generate an electric current. And the same thing goes for electricity as well. The electrons have to be moving through the wire to generate that magnetic field, right? Relative motion, inertia and acceleration, one of the two key modalities that rule the universe. So if we can understand that, then we can actually understand the dancing wires pretty easily, actually. So let's take a look down here. So we have the magnet, we have the battery, and we have the copper wire that's being wrapped around like this. The purple lines right here is just the magnetic field that's being generated by the magnet. Okay, so the copper wire is making contact with the positive terminal of the battery, It's coming around, it's wrapping around like this, and it's coming into contact with the magnet, which is a neodymium magnet, which is conductive just like the copper wire, right? So electricity can flow through it. Now, if you're using a ceramic magnet like this, which is like a dark, dull gray color, this is not going to work. And the reason for that is because ceramic is not conductive. Electricity cannot flow through them, right? So then we would have an open circuit and no electricity would flow. So this would not work. So we use a neodymium magnet, which is shiny like this. This is conductive. So now we have a closed circuit. Now we have electricity that's flowing through that wire, right? We're getting that relative motion just like we were talking about. So we got these electrons that are flowing through the copper wire, and that is generating that magnetic field around that copper wire, right? So we have this magnetic field that's moving around and around and around and around like that, and it's constantly interacting with the magnetic field that's being produced by the magnet itself. Okay, and as I'm sure you guys know, when it comes to magnetism, opposites attract and likes repel. Opposites attract and likes repel, right? So that's exactly what's happening here. This magnetic field around the copper wire is constantly being attracted to and simultaneously repelled by the magnetic field that's being generated by the magnet. It's taking that copper wire and it's physically moving it around like that. It's taking it and it's literally moving it. And that is the physics behind the dancing wire. And in its simplest form, this is pretty much a electric motor. That is exactly how electric motors work. Well, not exactly, but the physics is accurate.